You type a question into an AI and bam, a perfect answer pops out. But have you ever stopped to think, where does that answer really come from? I'm not talking about the data, I'm talking about the understanding, the meaning. Is it just sitting in a file somewhere? Today, we're going hunting for the ghost in the machine.
And this quote, man, it just nails the central mystery. We can see what goes in and we can see what comes out, but we can't just pop the hood and point to a line of code that says, understanding lives here. It's a complete black box, and we're about to try and take a peek inside. So, if we can't find meaning.txt on a hard drive somewhere, then what are we even looking for? Let's kick off our search for this ghost. Okay, first things first. To solve this mystery, let's start with what we do know. The stuff we can actually measure and see. Because from a pure engineering standpoint, a lot of this is actually surprisingly clear.
You know, on a nuts and bolts level, an AI is really just a giant, super-powered prediction machine. All these technical terms you see here, they all boil down to one job: tweaking billions of tiny digital knobs, or weights, over and over until the machine gets insanely good at just guessing the next word in a sentence. There's no ghost here. It's just a whole lot of math.
And we can literally watch this happening. We can see which digital neurons light up. We can track how the model pays attention from one word to another. We can map out the entire electrical cause and effect. But, and this is a huge but, seeing the lights flicker is not the same thing as understanding what they mean. It's like watching a circuit board light up without a clue what that circuit is actually doing.
Okay, so let's think like detectives here. If you're looking for the meaning of a word, where's the first place you check? Probably some kind of internal dictionary, right? Well, it turns out that line of investigation leads straight to a dead end.
And this is where things get really weird. A regular computer, it works the way our brains think it should. It stores the word dog in one spot and its definition over here in another. A neural network? Nope, it doesn't do that. There is no dictionary. There is no database of definitions. The whole way we've thought about computer memory for decades, it just doesn't apply here. So, if it's not a symbol, what is it?
And this brings us to our first huge breakthrough. The reason we couldn't find meaning as a thing is because it isn't one. In an AI, meaning is all about relationships. It's a location on a map.
So here's the big idea. Picture a massive, invisible universe with millions of dimensions, and every single concept is a point of light in that space. The meaning of any one concept isn't some definition written next to it. It's just its position, its location relative to all the other points of light. It's a single dot in a truly vast, interconnected web.
I want you to really let that one sink in because it's a total game changer. The AI doesn't know what a tree is in the way you or I do. What it knows with incredible precision is where the concept of tree is located in relation to every other concept it has ever learned.
Okay, let's make this real. Let's take a simple word like tree. If the AI doesn't have a dictionary definition for it, how does it give that word meaning?
It's all about proximity. The concept of tree exists in a neighborhood. It's statistically super close to concepts like forest, leaf, and wood. It's strongly linked to actions like climb and properties like shade. Now, here's the crazy part. If you could somehow go in and snip all those connections, all those relationships, the meaning of tree for the AI would literally just vanish. It would become a lonely, meaningless point in space.
And it is so important to get this. This is absolutely not how humans experience meaning. Our understanding is embodied. We know what shade means because we've actually felt the cool relief from a hot sun on our skin. Our meanings are tangled up with emotions, memories, and physical experiences. The AI's meaning is purely mathematical. It's a beautiful, complex web of statistics, but it's all built to just complete a task.
So, great. Meaning is relational. Mystery solved, case closed, right? Well, not quite. It turns out solving that puzzle just uncovered a much deeper one. The mystery of emergence. See, we get the how. That's the optimization part. We give the AI a simple goal: get better at predicting the next word. And it does. What we absolutely do not understand is the emergence, the why. Why does that one incredibly simple goal cause these incredibly complex abilities, like reasoning and creativity, to just pop into existence?
I mean, seriously, why does a model that is only trained to guess the next word suddenly learn how to write computer code or explain a joke? Where does that come from?
And why do its billions of connections, on their own, spontaneously arrange themselves into these complex circuits that actually look like pathways for logic? We never told them to do that.
And maybe the biggest head-scratcher of them all, why does just making the model bigger and throwing more data at it lead to predictable, measurable jumps in these new abilities? These scaling laws. It's like we've stumbled upon a new law of physics for intelligence, and we have no idea how it works.
All of this is pushing researchers toward a really mind-bending idea. What if an AI isn't like a computer program at all? What if it's more like a natural phenomenon? You know, like how a protein chain just knows how to fold itself into the perfect complex shape, or how neurons in a brain organize themselves without a blueprint. These things aren't following a list of instructions. They're following some deeper fundamental laws of self-organization, and an AI might be doing the exact same thing.
And this brings us to the final reveal. We've been asking the wrong question this whole time. We've been searching for a noun, an object, something to be stored. But the answer isn't a thing at all.
The real breakthrough isn't figuring out where meaning is kept, it's realizing that meaning isn't kept anywhere.
It's a verb. Meaning is an action. It's something the AI does, not something it has. It's a dynamic process that unfolds in the moment. Just look at this parallel. For you and me, meaning happens when our brain's neural patterns interact with our bodies and the world around us. For an LLM, meaning happens when its activation patterns interact with all that data and the specific prompt you just gave it. For both of us, human and machine, meaning isn't something you possess. It's something that happens.
So we have to throw out that old question. We need to stop looking for a filing cabinet that simply isn't there. The real frontier, the new ghost we have to chase, is this question right here. What are the fundamental conditions, the basic physics of the system, that cause meaning to spontaneously emerge out of pure complexity? Now that is a much more exciting mystery.